A cylinder is like a prism that has a smooth side, and the two bases are circles instead of squares or rectangles or trapezoids. As such, finding the volume and surface area is much the same. Now, for the surface area, finding the areas of the circles are quite simple. You just use the formula for that. So area of a circle is pi r squared. And to find the area of the smooth side of the cylinder, imagine taking a piece of paper, right? You have a piece of paper like this, and then bending it around. So like you're wrapping this side around to touch that side. If you do that, you'll see that you have a hollow cylinder. So you can think of it the exact same way. Whereas, right, this is where like the ends of the pieces of the, like this side would be right there, and that side would be right there. And what you're doing here is you're taking the circumference. Circumference is this circular length here, this distance around the circle, which is going to be the same thing as this, and the height of the cylinder, and that's the dimensions of this sheet. But the sheet of paper is just a rectangle, which means to find the area of this, you just take base, which is the circumference of the circle, times the height of the cylinder. So that's how we can find the surface area of cylinders, is taking two of the circles areas, which is the top and the bottom, and the circumference of the circle times the height of the cylinder. That gives us this surface area all the way around the cylinder. Now the volume of this is quite simple. It's the exact same idea as for the prism, right? We take the area of the base of the prism times the distance between the two bases. Cylinder is the area of these circles, which is, the base of the cylinder, times the height of the cylinder. That's the distance between the two circles. So this is going to be the height, and then this is the area of the circle. That's how you find the cylinders. Cylinders are very nice to work with. Their dimensions are pretty easy to use. It's nice to have a three-dimensional figure that has a little bit simpler formulas. Now, a sphere, I've kind of drawn it here with a shadow and a little bit of shading to kind of show you that it's three dimensionals. It's not just a circle. It's three dimensionals. I can't really show the reflection and everything. I can't draw it really well. So that's how I've shown this. The sphere is very, very simple. There's just two formulas for it. These really can be derived more with like calculus, but we don't have the means to do that in this class, so we're just going to be giving you the formulas for that. The surface area of a sphere is 4 pi r squared. R is of course the radius. It's from the very center of the sphere to the outside edge. It's the exact same idea as a radius in 2 dimensions for a circle as for 3 dimensions. So that's the area, the surface area of the sphere, and the volume of the sphere is going to be 4/3 pi r cubed, r being the same thing. Those are the formulas we're going to be using for these types of 3-dimensional figures. All right, here I have a cylinder and a sphere. You can see with the sphere we have the reflections and the lights kind of showing you that it's 3 dimensionals rather than a circle. Okay, for the cylinder, we have the base circles. We need to find the area of them for the surface area, right? The area of the circle for the cylinder. We need to have pi times the radius squared. Now the radius is this distance here. We're not given that, we're given this distance here, but that's just the diameter. And we know that the radius equals 1/2 the diameter. So 1/2 17 gives us 8.5. And the area of the circle is pi times the radius squared. I'll just show that this right here is 8.5. Of course, it's going to be in millimeters. We take pi times the radius squared. That gives us 226.98 approximately. I had to round it to two places. Millimeters squared. Okay, that's for one of the circles. Of course, we have two of them. But now we can find the surface area of the round part of the cylinder. So again, think about like a sheet of paper and unravel it, right? The circumference of the circle, the circumference of the circle, which is 2 times pi times the radius, which is 8.5. We need to know that because that's one of the dimensions of the rectangular piece of paper that I was talking about before. 2 times pi times 8.5. That gives us 53.41. I'm rounding it here, so I'll use the approximation. And the height of the cylinder is 28 millimeters. So we have the area of the smooth surface equals the circumference of the circle, of one of the circles, both the same, times the height of the cylinder. That's the same thing as length times width of the rectangular sheet of paper that I showed you before. Okay, doing that gives us 1495.48. And now the surface area is going to be the areas of the circles, there's just two of them, plus the smooth surface side of the cylinder. And I'm getting 1949.44. All right, there's the surface area of the cylinder. Now we can look at the volume of the cylinder. This one I told you was the area of the circle, which was 226.98. That we already found. And we're going to multiply it by the height of the cylinder, which is 28. Gives us 6,354.88, and this is going to be in millimeters cubed. The surface area was millimeters squared. Area, so it's a square unit. Volume is a cubed unit. All right, now we move on to the sphere. This one's quite simple because we can only really give you the formula for it. We have 4 pi r. The radius is given as 18 feet. So we have 4 pi r squared, and then of course the volume is 4/3 pi times the radius cubed. Doing those in a calculator gives me, I get 4071, of course going to be approximations, 50, and that's going to be in, this is 18 feet, so it's going to be feet squared for the unit, since it's an area. And for the volume, we get 24,429.02. This is going to be in feet cubed. Okay, we've got a bathroom sink here that is a hemispherical, which they say it's a half sphere, with an inside diameter of 24 inches. How much water can this bowl hold? If you think about it, we have like a bowl here, right? It kind of goes down to where the drain is, bottom of it. And it's saying that this distance here is 24 inches. Well, we don't need this distance, right? This is the diameter. What we need is the radius. Know anything about a sphere. So the radius is just going to equal half the diameter, which is 12 inches. Now, to find how much it will hold, that's the same thing as asking for the volume. And this is a half sphere. So we can find the volume of the whole sphere by using what we already know, right? The volume of the whole sphere is 4/3 pi r cubed. R is just 12 inches here. But this is a half sphere, not the whole thing. So all we have to do that is just divide this whole thing by 2. That gives us the volume of the half sphere. Put this in the calculator. I'm getting 3,619.11, and this is going to be in inches cubed. So that's the volume that the sphere can hold, 3,619.11 cubic inches of water for this specific sink.